Hello everyone. In this video we are going to find the value of sine of 18 degrees by the cosine of 72 degrees. Now one may wonder that we have found the values of trigonometric ratios for some specific angles such as 0 degrees, 30 degrees, 45, 60 and 90. But what is this 18 and 72? So we may have to find other ways of evaluating sine 18 by cos 72. Of course, one easy way would be just to feed into a calculator what is sine of 18 and what is cos of 72 and dividing. It is going to help you outright. But let us try to devise other ways of solving this with whatever tools we know. Now, let's consider a right angle triangle, because now this is going to deal with right triangles. So this is 90 degrees, and let this be a right angle triangle with one of the angles equal to 18 degrees. So if you say that this triangle is ABC, angle A is equal to 18 degrees. Now what do we know about angle C? If you know that angle B is 90 and angle A is 18, what do we know about angle C? Of course, we know the measure itself of angle C, because we know that sum of the angles in any triangle is equal to 180 degrees, and since one of the angles is already taking the measure of 90 degrees, the other two angles, A plus C, angle A plus angle C should be equal to 90, or in other words, A and C are complementary angles. They add up to 90 degrees, they are complementary angles, and if you do 90 minus 18, angle C is going to be equal to 72 degrees. So what have we arrived at by arriving at all this? Now let's recall that the definition of trigonometric ratios. I use a simple method to recall it, SOHCAHTOA, which just says that sine is opposite by hypotenuse, cosine is adjacent by the hypotenuse, and tangent is the length of the opposite by adjacent. So in case you forget, you can just recall this acronym SOHCAHTOA. And so now we need sine of 18 degrees. So what is sine 18 here? It would be the length of the opposite of the 18 degree angle, which is BC, by the hypotenuse, which is AC. Right, fine. We know this. Now what about cos of 72? That is going to be equal to adjacent by hypotenuse, or length of the adjacent, which is adjacent to the 72 degree angle, BC. Once again, BC is adjacent to the 72 degree angle, in the sense that both cos 72 and sine 18 cater to the same ratio of lengths, BC by AC. The one which is opposite to 18 degrees, the same side is adjacent to 72 degrees. So both of them are equal. So what do we infer from this? We have evaluated what is sine 18 by cos 72. It is equal to 1, isn't it? Because both are equal, it's equal to 1. Now, is there any other way of doing this without having to go into the right angle triangle? Yes. We have derived complementary angles. I'll give you the link in the description. We have already derived in our own math decoded channel also. We've done it, that sine of theta is equal to the cosine of its complement, 90 minus theta, isn't it? Now you just go and visit the video in case you haven't, or even otherwise in the same video we have also arrived at tan of theta is equal to its complement, or the ratio cotangent of 90 minus theta, and same way secant theta has been found to be equal to cosecant of 90 minus theta. Now let us use the first one for evaluating the sum which has been given to us. Let's use this. Sine theta as cos 90 minus theta. So let me rewrite the sum here. We have the problem given to us was sine 18 by cos 72, and we've already seen that 72 and 18 are complementary angles, so we can easily apply this one. So let me rewrite it. Sine 18, this is equal to sine 18 by cos 72 can be expressed as cos of 90 minus 18, right? Because 72 is 90 minus 18. So it's cos of 90 minus 18, meaning this theta is 18. So it is equal to sine 18, right? So sine of 18 degrees, once again, by the denominator also has sine of 18 degrees. So this is equal to 1. So using complementary angles also, we have arrived at the ratio sine 18 by cos 72, it's equal to 1. Now any problems given to you in this manner, like let me give you some examples of some problems involving complementary angles. It can be if you change the same problem to sine 65 by cos 25, sine and 65 and 25 being complementary angles, this is also equal to 1. Or if the problem given to you was, let me call this A, if it was tan of 26 by cot of 64, you would have guessed the value now. And the other one, cos of 48 minus sine of 42, right? I recommend that you try all these problems using these complementary angles, whatever we have found. Cosecant of 31 minus secant of 59. In each of the problems, you see that the angles mentioned are complementary angles, 31 plus 59, 48 plus 42, etc. So you can conveniently use these ratios, the complementary angles, to arrive at an answer. I hope you followed. Thank you.